a WikiVidi Documentaries production. Don't forget to like and subscribe. Enjoy. Speed wobble. Wobble, shimmy, tank slapper, speed wobble, and even death wobble are all words and phrases used to describe a quick oscillation of primarily just the steerable wheel of a vehicle. Initially, the rest of the vehicle remains mostly unaffected, until translated into a vehicle yaw oscillation of increasing amplitude producing loss of control. Vehicles that can experience this oscillation include motorcycles and bicycles, skateboards, and in theory any vehicle with a single steering pivot point and a sufficient amount of freedom of the steered wheel, including that which exists on some light aircraft with tricycle gear where instability can occur at speeds of less than 50 miles per hour. This does not include most automobiles. The initial instability occurs mostly at high speed and is similar to that experienced by shopping cart wheels and aircraft landing gear. Theory. Sustained oscillation has two necessary components, an underdamped second or higher order system and a positive feedback mechanism. An example of an underdamped second-order system is a spring and mass system, where the mass can bob up and down when hanging from a spring. If shimmy cannot be designed out of the system, a device known as a steering damper may be used, which is essentially a notch filter designed to damp the shimmy at its known natural frequency. Shimmy is usually associated with the deformation of tires. However, it can also be observed in non-deformable wheels. The phenomenon can be explained by introducing multi-component dry friction forces, apart from the usual forces considered in the literature. In two-wheeled vehicles, wobble or shimmy begins when some otherwise minor irregularity accelerates the wheel to one side. The irregularity may be a wheel which is out of round, out of true, or out of balance. As the wheel rotates, it will exert a cyclic load to the vehicle frame, which if matched with the system's resonant frequency, can produce a speed wobble. During the wheel rotation, a restoring force is applied in phase with the progress of the irregularity, and the wheel turns to the other side where the process is repeated. If there is insufficient damping in the steering, the oscillation will increase until system failure. The oscillation frequency can be changed by changing the forward speed, making the bike stiffer or lighter, or increasing the stiffness of the steering, of which the rider is a main component. While wobble or shimmy can be easily remedied by adjusting speed, position, or grip on the handlebar, it can be fatal if left uncontrolled. Other things being equal, speed wobble is generally less likely to occur in a mountain bike compared to a road bike, because a mountain bike's frame generally has more damping from the suspension system, and the tire knobs also produced some dampening between the vehicle and road interface. Since shimmy frequency is independent of bike speed, gyroscopic effects are clearly not essential to the phenomenon. The top 5 influences on wobble have been found to be lateral stiffness of the front tire, steering damper, height of bike center of mass, distance of bike center of mass from rear wheel, and cornering stiffness of the front tire. An academic paper that investigated wobble through physical experimentation and computer modeling concludes the influence on wobble mode of front tire characteristics, front frame inertia and chassis stiffness were shown. In particular, it shows that, by increasing front tire inflation, chassis stiffness, and front frame inertia about steering axis, and decreasing side slip stiffness of front tire, wobble mode damping is improved, promoting vehicle stability. Brought to you by WikiVidi Documentaries. Would you like to know more?